Okay, what I'd like you to do, please, is to make a new Java scenario, and we're going to call it Breakout. Breakout. And believe it or not, for this particular scenario, I'd like us to learn several different things. One of them is about how to use some of the built-in drawing and geometry tools from Greenfoot. Importing pictures and using a picture has been really helpful, right, and fun. But a very important part of Java's graphics program is the ability to draw and animate on the fly. And the Greenfoot's graphics program are built right off of the Java's program. So these methods are methods that you can use in many different packages, not just Greenfoot. So I think it's going to be really worth our while to spend some time talking about it. All right, what I want you to do is to double-click on this My World. We're going to change the name of it as well, okay? This is going to be called Breakout. Okay, this time with a capital B. So we're going to do the classic paddle and ball game. And you can put your name here because, well, we're going to start it together. You are going to make it your very own. All right, we've been talking a lot about making sure that we use constants instead of magic numbers. And so we're going to do that again. I like to have my curly braces in line, even though they don't. All right. So because they're constants, we can go ahead and make them public. And we're going to make them static so that they are formed before the call to the constructor. Public static final int width. And let's start with 600 by 600. And I think, you can play around with those numbers later. And since we'll be using constants, it should work just fine. So we've got two constants right now for the width and the height. Okay. And I want to make an instance variable, and we make all of our instance variables private. So private and int, and it's going to be a level. Now, for this demonstration, I'm just going to make level 1. Okay? All right, we need our constructor to have the same name as our class. So remember, the constructor is called when you say new breakout. Greenfoot calls the world constructor for us to construct the world. That's the entry point of the program. Static variables, though, are established before this gets called so that these numbers we can use right here in our super. So looking at the comment here, you'll notice it says create a new world with 600 by 400 cells with a cell size of 1 by 1 pixel. So I want you to keep that in mind, that this is the width, this is the height, so this is going to be a 600 by 600 cell game. If I make my cells something like 50 by 50, like we did in some of our, board game style games, this would be huge, much bigger than my monitor. So instead, we're going to have each cell be a single pixel. So we're not going to be doing so much of a cell-based game. We're going to be doing a pixel-based game. Okay, when the game first begins, I'd like us to start at level 1. So after super, remember any call to a super constructor has to be the first line of code. This comment being first is okay, but the first line of code has to be the call to super. And I'm going to set my level equal to 1. Okay? And now at this point, I'm going to make the bricks for my game. So I'm not gonna put that in the constructor. We don't want to have a bunch of like algorithms, right? We don't want to have a bunch of for loops in our constructor because we're going to be, when we're upkeeping our code and coming back and looking at it, we want our constructor to be a very basic list of what needs to happen for the game to begin. So first we have to create the game by calling the super constructor, set the level to 1, make the bricks. That's what we're going to do. So I'm going to say make bricks, and I'll put all my code for making the bricks that our game will bust through in a separate method. And we're not returning anything, so we'll make it void. So let's talk just briefly about how I'm calling this code. Remember that any method in the class that I'm currently typing in, or in the class that I subclass, such as world, or even any class that world subclasses, so any class that's your superclass or the class you're writing in, you call instance methods by simply saying the name of the method. You might have to say something like int x equals, get x, or something like that, but you won't call it on something. You won't say like world dot, because you're in that class. You just say the name of the method, so this call right here will simply move the control of the program down here. Well, we're going to come back to that because can't really make any bricks till we have some bricks, right? So we'll just close that. All right. So I want you to right-click on actor and create a new subclass. And I want you to call it brick. And we're not going to pick a picture right now, because part of this activity is about making pictures. So we've got a brick, and we're going to open up our brick class and we'll edit it here. This class is the class that makes bricks. So remember, classes are kind of like factories. Their job is to make objects. So our game's going to have lots of bricks. But we're only going to have one class to make them, because this class is a factory for generating bricks. All right, we're going to make a couple of constants. Constants that define the size of our brick. And because they're constant, the word final makes them constant. It's okay to make them public. And then by making them static, we know that they'll be formed before the call to the constructor. Without that word static, this wouldn't work. All right, and what I want to do is I want to make this constructor take in a color. Color is a class in Greenfoot. So to view that one, they don't have it over here. You have to go to Help, Greenfoot Class Documentation, which should open up in your browser. And you'll notice that color is right there. And so we'll come back and we'll talk about that more in a minute. Okay, so here's our plan. We're going to create an image we're then going to draw on that image, and I'm going to draw on it very simply. They do have some shapes that we can do in the image class, such as draw a rounded rectangle. If we want to make our bricks more rounded, we could certainly do that. And so I definitely would ask you to consider that. Let me show that right quick. These are all the different drawing techniques that you can use. So Greenfoot image. Once you make an image, you can draw a line. You can draw an oval if you want your bricks to be oval. You can draw polygons, rectangles. Lots of different things that you can do here. So the oval was a nice way to do it. You could even combine an oval with a rectangle, which works pretty darn well. And then fill rect will create a rectangle with the given color that you have. So lots of different things that you can do to make your pictures be unique. But I'm going to take the easy road out right now and leave you the task of making it more interesting. And I'm simply going to make my color one. I'm just going to fill the whole thing. So Greenfoot image. We're making a new Greenfoot image. So let's review, how do we make an object? A Greenfoot image is an object. First, I need to type the object. What type will it be? A Greenfoot image. Now I need a variable name. IMG, that's my variable name. Now to make an object, I need to use one of two things. I either need to call a method that returns an object, like say getWorld will return a world instance, or, as is more commonly the case, I need to call the constructor from that class. So we're making a Greenfoot image. Let's go to the Greenfoot image class. Let's see what constructors we can do. Well, we can call Greenfoot image with another Greenfoot image. We can give it a file name to load an image file. We can call it with, let's see here. That we can give it an image with a size, a foreground, and a background. So lots of different things we can do. We could even an outline color, which would be different than the background color. So lots of different things you could do, and I hope you explore different ways you could have a different, color, background, foreground, all those different things. But for me, I am simply going to use this constructor here that takes an int width and an int height. So that's what I'm going to do. I'm going to say new Greenfoot image width, comma, height. And it creates it. Remember that width and height variable is static, so it is formed at compile time. So when we create a brick, they're already formed. Now I'm going to set the color. I'm going to be setting the color to the color value that was sent to my constructor. So I'll be determining the color somewhere else. And I think this makes a lot of sense because that allows us to, when we create bricks, when we operate our brick factory, if you will, we'll be able to say, I want some red bricks, want some yellow bricks, and they'll automatically be chosen based on the color we give. So I've set my color, and now what we're going to do is we're going to go here and use this fill method. Let's click on this. Again, I'm in the Greenfoot image class that we get to from the help. Let's click on it and see what it says. It says fill the entire image with the current drawing color. So I've set my color. This didn't change the color of the image. This sets my drawing color upon this image. img.fill. All right. So one more quick break here. I want you focused on how I call methods. Set color, fill. Those methods are not in the actor class. Let's look at the actor class. Here's the documentation. Set color, not here. Fill, they are not. It is not here either. I do not have a method. I didn't write something like public void fill, did I? Don't write that. But I just want you to know, I don't have that, right? If I did, I would call it just like this, right? But I don't have that. Where is it? What does it belong to? Fill is in the image class. Image, Greenfoot image. So in order to call it, I must have a Greenfoot image, which I get with the new operator right there. And then I call the methods on that variable img, which should make sense because I'm not setting the color of the brick here. I'm setting the color of the image of the brick. I'm filling the color of the image of the brick, right? Okay, one last thing. Now, I want to set the brick's image to the image I just created. So how do I do that? Well, setting the image, now that is in the actor class. See that? Set image. And they have two of them. You can either give it a file name or a Greenfoot image. We're going to give it the Greenfoot image we just drew. So set image is in the actor class. Brick is an actor because it extends actor. So I inherit all the methods from actor. As much as if I had written it right here in line 18, you can imagine. So I simply say set image. Just to drive that home, the keyword is called this. In Java, what I'm saying is essentially this.setImage. I did image.setColor, but now I'm doing this. What's this? This brick that I am making in my factory. Stylistically, though, this is, while doing something like this is very preferred in Python, in Java, we don't do it. It's implied. With that, when there's nothing in front of the word of a method, it means you're doing it to this instance. Okay. Okay, I want to look now at how we would create a brick. So if I right-click on it, I can't just say new brick because it's new brick color, right? So it's going to ask me to supply a color. See how it says color? It's very hard to see. It's in gray. Color with a capital C and then lowercase c. Oh, you can see it right here. Well, the capital C is the class type. So it's telling me, hey, it's saying, Jed, before you make a brick, I need a variable. That variable needs to be a color. So let's go to the color class of Greenfoot. It's right here. Let's check out the constructor. The constructor takes an RGB or an RGBA. RGBA is so cool because alpha is transparency. We can actually make our brick somewhat transparent or translucent or whatever you want to call it based on an alpha value, which is really cool. RGB, if you look at your pixels under a microscope in your monitor, each pixel is really 3 bands of light bulbs. A red one, a green one, and a blue one. And so every color that we make is based on a range of 0 to 255 in red, 0 to 255 in green, and 0 to 255 in blue. So let's do that. Let's create one. Now, I'm just going to make an anonymous object here. So usually you have to, make and store a variable. But I can just say new color. And I'll give it a red value of 128. A green value of 0, and a blue value of 0. Oh, wait a minute. It can't find color class. Oh, I guess because we haven't imported. All right, well, we can't do it from here. That's all right. We'll do it from over here. We'll do it in the breakout world. Let's just do it right quick. Oh, my God. That's being ridiculous again. All right, hold on. I'm stressing out my Greenfoot. Okay. Oh, we're back. All right. So let's make a brick. Let's just add an object here, okay? So add object. Add object is a method in the world superclass, so I call it directly. I call it directly here because I'm in a world class. If I was in, say, my brick class and wanted to add an object, I'd have to get an instance of the world, call it something like W, and then say w.addObject. But because I'm in the subclass of world, I just say add object. I want to add a new brick, and the color, say new color 128, 0, 0. That's my new brick. And then my X value of, let's just say 100, 100. And we got a brick. At X value 100, Y value 100. It's that rectangle filled in. So that's the color that is 12800. So you can play with the different colors. Now I'm doing a lot of coding in the line here. You might prefer to see how this would look like on each different step. Well, to make a brick, we need a color. So I can say color C, call the constructor, new color. Let's do 100, 200, 0. Okay? That's a color. Now we'll make a brick. Brick B equals new brick, and the brick takes a color. And then finally, I can add the object B, my brick, to that location. So that's the same kind of thing. I did a different color, so that's the same kind of thing. But I did it one line at a time. I made the color, made the brick, and then added it. And you can see it's kind of a greenish, lime green. So you don't need to change the code. If you're happy with what it looks like, that's fine. I just want to show you how does this become in one line. Well, since we're only using the color one time, I make the color in line 25 and I use it only in line 26. I don't have to keep a reference to it. I'll never be able to find it again. It'll be just gone to the Netherland. But if I'm only going to use it one time, I can actually create it in there, right? Now this code works as well. Now, since I'm only using this brick one time before I add it, and then adding the object actually does keep a reference to it because I can get the objects at a certain location, I can simply take this line of code here and make it just right there. And that's how we created a brick of a certain color all at once. Okay? All right. A little bit more about colors. You'll notice that just like our brick and breakout class, they have made some public static constants for us to use. In the documentations, constants, when you say final, they're called fields. And look at them. Well, what they are preloaded values of R, G, and B. So they have gone through and made a bunch of these different instances of the color class for us. We could certainly make our own colors and make them constant. So we don't have to use the RGB. We can simply use these constants. Now remember how you call a constant. It's static, so you call it on the name of the class. It's a field, not a method, so you just say the name. And remember, constants stylistically should always be all caps. So I'm going to use the color.blue method. So let's try that. So instead of saying new color, I'm just going to say the name of the class color and .blue. Okay, I'm getting some problems here. Oh, I don't have enough parentheses. Okay. Well, I'm still having issues. Oh, I got the parentheses in the wrong place. All right, did I finally do it right? So what I'm doing is I'm saying brick B equals new brick color.blue. So that's how you call the brick constructor. And I was just doing it in the line, but let me do that. If you ever get, sometimes it's just too complicated. You get too many parentheses. So I made a brick in line 25 using the static constant blue from the color class. And there we have it. I got a brick. Okay? Now I think I would like to make lots of them. All right, let's make some bricks. I remember we set a value for the level. So in this particular case, I'm going to start with if level equals 1, I'm going to make level 1. So you could see that each different level could call different brick makers. So the constructor will call make bricks, which will send us here, which will then decide which level to make. So public void make level 1. So we have the constructor calls this kind of like almost like a depot, or you might think of it as like a router that will route us to making the different level that we should make. All right, so we've worked with this a few times, but I want to write code that will move like a typewriter from left to right and then move down like this. To move from left to right, I'll simply use a loop for the x's. So let's start with that. So I want this to be, I'm thinking 50 pixels to the right of the game. So I'll start with 50. Now that's kind of a magic number. We would probably be better to make a variable for that. But for now it's okay. And I would like to go as far as the width of the game minus 50. So I'm going to start at the x-coordinate 50, and I'm going to go as long as the x-coordinate is to the left, or less than the width of my game minus 50. I'll want to increase the x-coordinate by 50 each time. All right, I'm going to make a brick. And I'm going to make this brick blue. And I'm going to add an object. I'll be adding that brick. And I'm going to add it at the x, y coordinate. Oh, I don't have a y coordinate yet. Let's just make a y coordinate. How about 100? We're going to come back and make a y value later. So this is going to add all of them to the y coordinate 100. So 100 down from the top. But it's going to do the x value. So let's think of how many bricks this is going to make. It's going to start at 50. Then x will go to 100. That's 2. Then 150. Then 200. Then 250. 300. 350. 400. 450. 500. 550. So I think 11 bricks, right? Because the width is 600 and this is less than or equal to. It's going to make 11 different bricks. Each one's going to be added, but the x value they're added at will be changing. Let's take a look. There we go. So that's the power of coding, is it made a lot of them. Now, that's just one row. We can now make another row by doing the same thing. So let's say for int And this X is available to me now. It's not going to get mad at me for reusing it because we declared X in this for loop, so it's dead by 34. It's erased, so I can make it again. This time I'm going to add it 30 pixels down lower. So the Y coordinate is now more than it used to be. Okay. And that should generate, I made color all caps. Sorry about that. So that should generate a second row of bricks that are red. And again, if you don't like the default colors, you can always use the RG give new brick and give it 3 numbers, each number from 0 to 255. And there we have it. So I'm doing a pretty boring design, but that's okay. All right, now I'm actually going to change this. I am going to make it to where my bricks make several rows all by themselves. So what I'd like to do is get rid of this second for loop, right? That was just for demonstration purposes. Let's get rid of it. And I want this X's to repeat over and over again. So instead of me making a different for loop for every single row, let's make a for loop for the rows. And instead of calling my variable rows, I'll call it Y. And I'm going to start my Y at 50. And I'm going to go for Y less than or equal to 200. And I'll increase by 30. So if you take your mouse and highlight the entire thing that you want to indent and then press tab, it'll indent over. If you go too far like I have here, hit shift tab and it'll go back. So now we are magically going to have several rows. We'll have a row at Y coordinate 50, 100, 150, and 200. But I need to change this 100 to a Y. So now it'll be at 50, then Y will become, actually it'll be quite a bit more because it's going up by 30. Very important you understand the order. It's going to make Y equal 50, and then Y will remain 50 the entire time this inner loop is running. Not until this entire loop where X goes from 50 all the way up to this is 550, that will finally end. Then Y will finally increase to 80, and then X will start back over. So it's going to make it like a typewriter. It'll do the whole first row, then the second, then this one, next one, next one, next one. Okay? All right, well, this is kind of boring, though. Right? Because they're all blue. Let's add some variety. So I'm going to say up here, I'm going to go import java.util.arraylist. And I'm going to create. So ArrayList allows us to make a list. And we remember we can add, get, set, remove, and get the size. So we'll declare the variable here. Private ArrayList. Now, when you type, Java is strongly typed. So when I make a variable for an array list, I not only have to tell Java, hey, Java, I'm making an array list. Java will be like, okay, great. I'm glad you're making a list. What will you have in your list? And that we put in these angle brackets. And I am going to be giving it a color. And we'll just call my list colors. So we're making a list. And the list is going to be a listing of colors. So before I can make my bricks, I've got to make my colors. It's not going to do me any good to use my colors to make my bricks if I haven't made them yet. So we get to write that method now. And remember, this method is in the class Breakout. So when I call it, I just say the name of the method. Now, you can be very creative and you can use all sorts of different combinations of RGB. You got 256 cubed different choices. I'm just going to grab a few of these static constants and add them, okay? So I'm going to say, first, you have to, I can't do this yet, okay? Why? Because colors is currently a null, because I haven't actually made the list. So I have to say colors equals new array list. Okay, and it turns out for about 5 years ago, they made it to where you no longer have to put that in there. It actually does it automatically based on whatever you typed it as. Now I'm going to add my colors. So I say colors.add. And there's several different static colors already made for me. I'll say blue. Colors.add. Color.green. Colors.add. Color.magenta. That looks good. Colors.add. Color dot orange. And I may want to come back later and actually change the order that I've added these if I don't like maybe I don't like orange, red, yellow. In fact, I don't. So I am going to change the order. I'd like to kind of move that around a little bit. Okay, so we've got our colors now added, so we can use them. So I'm going to use them here. So I'm going to make a variable in my level 1 called int color number, maybe? How about colnum for color number? And I'll start at 0. The first element in a list is at index 0. All right. So the color that I'm going to be doing here is going to be colors dot get colnum. Now, color number, if I get 0, if I say get 0, that would actually make every one of them blue. Okay? And you see they're all blue, right? But if I then change colnum by 1, now they're going to get a different color over and over again. But there's a problem, because once I only have 1, 2, 3, 4, 5, 6. Once color number reaches 6, it's going to be an error, because I don't have a color in index 6. So I need to have a way to reset this. So I'll just say if colnum equals colors dot size, remember that if we have a list of size 6, then the indices are 0, 1, 2, 3, 4, 5, which is 6 numbers, but it ends one less. So if I get to, after adding 1 in line 47, if my color number is now equal to the size of my colors, I need to start that over. So it will now just zoom through all these colors, and when it reaches the end, it'll start over. And we get kind of a cool little effect because we have an odd number of bricks that makes it, we have a different number of colors than we do bricks in a row. So they have kind of that staggered effect, which is really kind of neat. I like. And yours might look slightly different than mine based on, how you set yours up. So there we go. We've got our bricks. There is a better way to do what we just did here. And the way that you do that is you get color number mod colors.size. And we're going to do a unit where we talk about math coming up in a little while, and this will make more sense. But mod gets the remainder. And when you do that, it means that as color number increases over and over and over again, mod means the remainder when you divide it by the size. So, for example, if color number reached 6, 6 mod 6, well, 6 divided by 6 is 1 with a remainder of 0. So it starts back over. So you'll see this modding by the size. So you can either do that, and then you don't have to do this if statement, or you can leave this off, and you have to do the if statement. Okay? As you get better at understanding modular arithmetic, you'll probably stick with the mod. But they both work. Computer doesn't care, so I don't care right now either. All right. Okay, we have made level 1. Now, we need to, well, do something, right? We can't really do anything yet, can we? So, let's make a ball. Y'all ready to make a ball? Okay, so the next thing we're going to do is we're going to make a ball class. So we'll go to actor. We'll say new subclass. And there are lots of different objects we could use for a ball. We could also draw our own picture, but that's not what we're doing today. Today we're trying to use this as an opportunity to learn about image drawing. So we're going to draw our own ball. So we won't supply an image. We'll just say new class ball. All right. We're going to need an act method here in a while, but for now, let's just erase that for a second. All right, I want to make some constants so that we have a way to describe our ball very quickly and easily and make changes that will go throughout our code as needed. My ball will have a certain radius. And since it's going to be moving, I think it makes sense that my ball have a certain speed. So if we were outside the class, we would access the radius because it's static by saying ball.radius. The speed of the ball will be ball.speed. And because this is a static variable, if we were to have, say, like a multi-ball situation, each of those balls would have a speed of 6. And we would, if we wanted to make the balls have a different speed, we would have to change speed to an instance variable, which would be different. All right. So let's say public ball. And when I make the ball, I would like to have the ball have a rotation. So The movement of an actor in Greenfoot is based on its rotation. We do have set location, but if we use move will move this actor in the specified distance in the direction it's facing, and the direction is set by rotation. So I would like to have the rotation be set here upon constructor of the ball. That way, if we had like a multi-ball situation, we could have one ball go one direction, one ball go another. Okay? So I'm going to allow the users of my class, which will, when I say users, it's oftentimes me. I'm the user usually, but could be someone else. Public ball int rotation. Rotation is a set of degrees, 0 degrees to the right, and then 90 degrees down, then 180 to the left, 270 up, and then 360s back around again. But you can also use negative rotation values. So set rotation. Please remember that the first line of code in any constructor is this. If you need to call the superconstructor with different parameters like we do in our world class, you must put them in there. Java does not show this because it doesn't require you to type it. It does it for you. But it's important you know that it's there. So after calling the actor superconstructor, we're going to set our rotation. Now, let's make our image. So take a moment and practice making your own image object. I want you to set the color of the image, and I want you to make an oval with that color of size radius. Okay, so this is how I would do this. First, I need an image, and that's an instance of the Greenfoot image class. So we type it. We say, okay, Java, I'm making a new variable name. And Java says, what type? I say, it's of type Greenfoot image. I give it a variable name, img, image, whatever you want to call it. We create a new object by saying new Greenfoot image. And Greenfoot image takes a width and a height. So I'll take radius, please. Well, actually, that doesn't really make sense, does it? Because the width and the height should be radius times 2. You know what I'm realizing is that this radius is not a radius, it's a diameter. Let's change it to diameter. All right. Sorry about that. Just now dawned on me that this whole time I thought I was using a radius. I was not. I'm just going to confirm that to make sure that the fill oval, because we're going to use fill oval, which uses a width and a height, so it's really a diameter. Okay, so here we go. First, I'm going to set my color. I would like to be, I would like my ball to be black. Now, if we wanted to allow the different balls to be different colors, we could certainly do this. We could go right here and we could say, we could add it to our constructor. You don't need to do this right now, but we could do this. And that would allow us, when we make a ball, to set the color. But it would also require it. So what would be nice is to leave it like this, and if we decide later that we want to be able to set the color of the ball, we can make a second constructor that takes it as a parameter. But I'm fine with just doing this right now. Okay, if you search through the Greenfoot image class, hopefully you found the fill oval method. The fill oval method takes an X and a Y of the upper left-hand corner. That's the upper left. Remember, I just click on the method to get the details. Y is the upper left as well. Width is how wide and height is how wide. If I want it to be a circle, I make width and height the same, which makes them diameters. So we'll say image dot fill oval. Remember, we're calling a method in the image class. We're calling an instance method. It doesn't say static. If it's in static, I would say Greenfoot image dot, but it's instance, so you have to call it on an instance of Greenfoot image, which we are, called ing. And so I'll say fill oval. Upper left-hand corner will be 0, 0. And I'll make the width and height the same. Okay. We've created the image. We just need to set our object to that image. Our actor. The actor method is set image. It's in the actor class, so I just say it directly, and I give it the image I want to set it. All right. So now we can actually bring a ball out. I'm going to say, I don't know, negative 45 degrees. And there's our ball. All right. Let's go to the ball, and let's go to the act class, the act method. So public void act. This is a method that is actually already written in the actor class. It is called every frame. And in the actor class, it looks just like that. It's completely blank. So what we're going to do is just fill it in. We're going to override it. So now it will run this act method. And we're going to start with that. We're actually going to have a few more lines of code here. But we'll start with move speed. Let's test it out. I'll get a ball. I'll give it a rotation of negative 45. And I'll run it. And there it goes. You can actually set your actors to run off the screen. But by default, the default actor is that it will actually be confined to half on. Let's make another ball. This time with a rotation of, let's see here, 180 is 100%, one is right to the left, so let's do like 225. So you see how the rotation sets the direction that the ball moves. All right, well that's good enough. All right, so our next goal here is to make our ball bounce off the wall. It currently is not. We'll need to keep in mind that the XY location of the actor is actually the center of the actor. So we'll be needing to keep that definitely in mind on how we do this. So we're going to say if on wall bounce. So I'm not using if as a special keyword there. That's the name of my method is if on wall bounce. So if it's on the wall, we're going to bounce. And we need to do that before we move. All right, remember when you call a method that you wrote in your same class, you just say the name of the method. So public void if on wall bounce, I just call it directly. So let's talk a little bit about how this is going to work. The ball, if it's coming to the left, it's going to hit the wall, and then it's going to change its angle. If the angle is going to the left, that's 180, we're going to come back at an angle of 0. if we're going at an angle of, say, this would be like 130, we're going to come off at an angle of 50. So let me draw that for you so you see what I'm talking about. So if I've got a wall, and a ball comes in and hits it, okay? The angle that it hits at here, if we call this angle angle A, okay? So that's like A degrees. Whatever angle that is, that's the angle that it will come off at. It's an important part of physics called the angle of incidence is equal to the angle of reflection. So angles in Greenfoot are actually measured from 0 to 360, and they're measured clockwise from the horizontal. So let's say that this was like 120 degrees here. Well, if that's 120 degrees, geometry tells us this is 60 degrees. Right? And then this is a right angle, making this 30 degrees. Which would make this 30 degrees. And since this is a right angle here, if this angle is 30, this angle must be 60 degrees. So we had an angle, as we approached the wall, we hit the wall at a 120 degree angle, and we bounce off at a 60 degree angle. And it turns out that if whatever angle this is, even if that angle is positive, if that angle is x, this will be 180 minus x. Let me show one more example. So that was when it's going down. Let's say we have a ball that's coming up. Okay? I'm going to say, all right, this angle is measured. Remember, in Greenfoot, they are measured from the horizontal this way. So it's all the way around. Let's say that that is like a 240 degree angle. Okay? Well, if that's 240, we know that halfway around would be 180. So that makes this 60 degrees. But if that's 60 degrees, this is 30. Well, I already did 60 degrees. Let's do a different one. Let's say this was a 230 degree angle. Well, if that's 230, that makes this 50. Because it's 180 to go from here to here, and I need another 50. The angle has to be the same that it bounces off at. Well, if that's 50, and this makes a right triangle here, this must be 40. But if that's 40, we know from physics that this is 40. But that's a right angle, which makes this a 50 degree angle. So what is this angle here? Well, it's 180 minus 50 is 130. So how would we get that? Is that right? Well, what is I said whatever the angle is, you just have to subtract it from 180, right? Let's do 180 minus 230. What is 180 minus 230 equal to? Negative 50. I've done something funny. Hold on. All right. So what we get is negative 50. Well, what does that mean? Why does that work? It works because we should be going upwards, right? we came this way. We should be going upwards. I said 130. That's not the right thing to say, actually. Well, this angle here that we're saying, we're going to set it with negative 50. Well, remember, angles can be measured positive or negative. So this angle here, we can go in the same direction. We can either say, okay, let's set the angle all the way around, which should be 310. But we can also just say, hey, negative 50. Negative 50 means rotate counterclockwise. So we still get the right angle because we get a negative angle. Now, Greenfoot will convert it to positive 310. But it's easier to see it over here, isn't it? But with this one on the right, you can see that because of the negative angle ability, it still works. All right. All that being said, to bounce off a wall when you're going to the left, you simply have to subtract. All right, apparently I'm misspelling my methods. There it is. Okay. So here's how we're going to do this. If get x, now x is the center of the ball. So the x coordinate minus the radius divided by 2. Not radius, diameter divided by 2. So the center of our ball is the x coordinate we get from saying get x. If I take the diameter of the ball and divide that by 2, that's the radius. So get x minus diameter divided by 2. If you want, you could say like int radius equals diameter divided by 2. Then I can just say, hey, if the center of the ball minus the radius, is less than or equal to 0, we need to use less than or equal. We're not sure that it's going to perfectly hit the wall. It might actually go a little bit into the wall. Then we need to bounce off. And I'm going to show you a rookie mistake so you know to avoid it. The method to find the current rotation, the angle of rotation, you get it of the actor by saying get rotation. So we're going to set the rotation to 100 degrees, 180 degrees minus the current one. Y'all, this is a big time rookie error though. You can get away with this sometimes if you're really careful about the order you do things, but it's a problem. And you'll see this from time to time when people try and make collisions. Y'all, collision detection's tough, okay? But what happens is you'll see this. You can see this anytime when you see people making collisions who haven't done it a lot. What they'll do is they'll make a ball, okay? And the ball will come up this wall, and then all of a sudden it hits the wall, and it'll start zigzagging. And the problem is that if we say 180 minus get rotation, what if the ball is still touching the wall? There's a moment of time, you can think of it in real life, when you throw a ball against the wall, it squishes against that wall. If we change the rotation every time we're touching that left wall, we could end up being going left, right, left, right, left, right, left, right, left, right forever. What we want to do is we need to realize that we're only going to change the rotation if we are currently impacting that wall, which means we are moving left. So we're going to use the double ampersand. We're going to say, and moving left. Now, this method is not in the actor class. We have to write it. So we're adding this extra thing. We're saying, hey, look, don't try and reverse my direction if I'm already moving to the right. So when we hit the left wall, Right? That's what this is. Less than or the x value less than or equal to 0. That means hitting left wall. That's how you hit a left wall. You have to be moving left. Because we could be touching the left wall but moving right because we've already hit it and bounced off. So we're going to write that method. Let's write it. We're going to write the method that tells you if we're moving left. It's got to be a Boolean because I'm asking it. I'm asking and true or false, right? So public Boolean. So how do I know if I'm moving left? Well, we know from the angles that you're moving left if your angle is pointed this way, anywhere. This is 0, 90 degrees, 180, 270. So if my angle is greater than 90 and less than 270, so if I have an angle anywhere in here, I'm moving to the left. So that's what I'll return. I'll say return get rotation greater than 90 and get rotation less than 270. We're going to go ahead and write moving right, moving up, moving down so that we can finish the wall bouncing. And then that'll be a good place for us to stop. You're moving right if your rotation, we could simply say return not moving left. But yeah, we could just do that. Public Boolean moving down. Well, down is any angle from 0 to 180. So I'll return get rotation. Now, you can set your rotation with negative angles, but Greenfoot will automatically convert it to an angle between 0 and 355. I'm sorry, 359. So as long as the get rotation is less than 180 degrees, that means it's from 0 to 180. We must be moving down. And we can also write public Boolean moving up, which just means you're not moving down. And it's just going to make it easy for us to make our code. So now we've got four methods that tell you they return true if you're moving in that direction, false if you're not. Now, once everyone has that, we're going to go ahead and use them to finish the wall bounce. So this handled hitting left wall. That was hitting left wall. Let's do hitting right wall. So if get x plus radius, remember I calculated the radius in line 28. If that is greater than or equal to the width of the game, well, we made a constant for that called width. So that means I'm touching the right wall. So if you're touching the right wall and moving to the right, if touching the right wall and moving to the right, then we're going to set our rotation to 180 minus get rotation. because it works just as well on the right-hand side as well. Lastly, we're going to do hitting top wall. And this one's a little different. So if the y coordinate plus the radius is the top wall is a y coordinate of 0, and we are moving up, we're going to set the rotation to 360 minus get rotation. And I'll have you work through the geometry to understand why that one's 360 minus. So we have a plan for hitting the left wall, hitting the right wall, and hitting the top wall. And now we should be able to test this and make it work. I'm missing a parenthesis. One thing I want to point out, though, last thing I want to point out is you'll notice that moving up, moving right, moving left, they return true or false. I am not saying this. Do y'all notice that? I'm not saying and moving left equals true. This is the tendency that most beginning programmers do. It works perfectly fine, but it's not necessary. Because you're just saying and true equals true. Just let it say and true. Okay? It makes your code very readable. All right. We'll compile that. Let's add a ball. I'll set the rotation to negative 45. And I'll run it. And hopefully we see some sort of bouncing. Oh, I got my top wall mixed up. Oh boy. Is my moving up? Not moving down. Get rotation less than 180. Oops, I did. Big mistake. Remember, the get y is the center of the ball, and the y's get values get bigger going down. So I actually need to do minus the radius. So I had mine go off the screen and get stuck, which should actually never happen. So please do get y minus radius for the top wall. And then you should be able to create a ball. Let's do 225. So that should point off to the left somewhere. And we should see it bounce off the walls. We don't have anything with the bottom wall yet, so it'll just get stuck down there. But that's okay. All right. So in the next video, we will finish this up.